Physics Part 231. Putting two charged polythene rods close to each other, or two charged acetate rods close to each other, shows that similar charges repel each other. Conversely, unlike charges attract each other. A charged polythene rod attracts a charged acetate rod. This is the basic law of force between electric charges. Like charges repel, unlike charges attract. Charged rods will also attract uncharged objects. A charged polythene rod will pick up small pieces of paper, for example. The presence of the negative charge on the rod causes a redistribution of charges in the paper. Free electrons are repelled to the far side of the paper so that the side nearest the rod is positive and is therefore attracted to the rod. The paper is said to be charged by induction. When the rod is removed, the free electrons will move back and cancel the positive charge. Force between charges. In the late 18th century, the French scientist Charles Coulomb investigated the magnitude of the force between the charges, how this varies with the charges involved and the distance between them. He discovered the following rule: the force is proportional to the product of the charges and inversely proportional to the square of the distance between them. This is known as Coulomb's law. Coulomb's experiments made use of small charged insulated spheres. Strictly speaking, the law applies to the point charges, but it can be used for charged spheres provided that their radii are small compared with the separation. For point charges Q1 and Q2, a distance r apart, Coulomb's law gives the force F as F cross Q1 Q2 over r square, where F is equal to KQ1 into Q2 divided by r square, where K is a constant proportionality, where K is a constant proportionality, the value of which depends on insulation medium around the charges and the system of units employed. In SI units, F is measured in newtons Q, F is measured in newtons, Q in coulombs, and R in meters. Then the constant K is given as K is equal to 1 over 4 pi E0. And so F is equal to Q1 into Q2 divided by 4 pi E0 R square. When the charge is in a vacuum, the quantity E0 is called the permittivity of free space or the permittivity of a vacuum. The value of the permittivity of air is very close to that of a vacuum, 1.0005 E0. So the equation can be used for the force between charges in a vacuum or in an air. The value of permittivity of free space is given by E0 is equal to 8.85 into 10 power raised to minus 12 c square into Newton per meter. We shall meet an alternative unit for E0 later, that is FM power raised to minus 1. The numerical value for E0 means that K is equal to 1 over 4 pi E0 is equal to 8.99 into 10 power raised to plus 9 C minus square and M square.